Welcome to lesson 3.6, solving decimal equations. So to begin with, I just threw on here a decimal place value chart because in this process we will be doing a bit of rounding. So again, remember your place values in front are the ones, tens, hundreds, and so on. And after the decimal, one decimal place is the tenths, the second decimal place is the hundredths, third is the thousandths, fourth would be 10,000ths, and so on. So the idea of rounded solutions, especially when we're dealing with decimal linear equations or decimal equations, rounded solutions may be used when an exact solution is not practical. So rounding answers can lead to what's known as round-off error if they're not used in situations where appropriate. And the best way to avoid round-off error is to not round your answer until the final step or your final solution. So then we have an example here. If we're dealing with money, we would not want to deal with hundreds of decimal places. We would most of the time find it practical to round to the 100th place or the nearest cent. But again, in order to be accurate, we would not want to round until the very last step in the process. So let's look at a couple examples. Example 1 says to solve the equation and round your answer to the nearest hundredth. So again, the process with decimals is no different than if we're dealing with whole numbers or fractions for solving for a variable. So in this case, we have a variable on both sides, so we want to isolate the variable and get it to one side. So what I decided to do was to subtract the 0.23x from each side. So 3.58x minus 0.23x gave me 3.35x minus 37.40 equals 8.32. Then, to further isolate the variable, add the 37.40 to each side, so that cancels on the left, and we have 3.35 times x equals 45.72. And then the last step to solve for x would be to divide by the 3.35 that's attached to x. So divide each side by 3.35, and you'll see if you use your calculator, x is 13.64776119, so on. But again, we're rounding that to the nearest hundredth. So in the hundredth place currently is a 4, followed by a 7. So that tells us to round the 4 up. So we would have x being approximately 13.65, and the squiggly equal means approximately. In example 2 says solve and round your answer to the nearest tenth. So in this case, we're rounding to the tenth or one decimal point, but we won't do that till the very last step. So I added 49.5 to each side, making it 54 minus 7.2x equals 3.4x. My variable is still split to both sides, so I want to get that over to one side. So I added 7.2x to each side. So then on the left, I'm left with 54, and on the right, 3.4x plus 7.2x is 10.6x. So then we want to solve for x by dividing each side by 10.6. So x would equal 5.094339, and so on. Now, if we're rounding that to the nearest tenth, we have 5.0 followed by a 9. So that would round the 0 up to a 1. So we would have x being 5.1 when we round to the nearest tenth. So again, if you're simply dealing with solving for a variable in an equation setup, you follow the same rules that you did for all of our whole number equations or fraction equations, and then you round in the very last step. Our third example is dealing with a word problem. So in this word problem, you're shopping for a pair of earrings. The sales tax is 5%. You have a total of $18.37 that you can spend. What is the price limit for the earrings? So we know what our total is that we have in our pocket. We know the tax, but we want to figure out what's the limit that we could spend on the earrings before tax. So then our verbal model would be the price limit plus the sales tax rate times that price limit equaling the total cost. So we would have whatever our price limit is plus the sales tax on the price limit equaling the total cost. So if we label these from our verbal model, the price limit would be x, the sales tax rate of 5%. To convert any percent to a decimal, you divide it by 100. So we'd have 0.05. And then our total cost is the $18.37. So using these labels, convert our verbal model to algebraic. So we'd have x plus 0.05 times x, so our sales tax, equaling the $18.37. So 1x plus 0.05x is 1.05x. 1.05 times x, so to undo that, we divide by the 1.05. So then x would equal 17.4952, and so on. And now we're dealing with money again, so we know we'll be rounding to the nearest hundredth. But the problem is here, if we would round up to the next cent, we would go over our price limit. So no matter what in this scenario, we cannot round up. So we're not going to round up from the 17.495 to 17.50. We're just going to leave our price limit at $17.49.